The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Thank you for joining us today for our Safety and Handling of Permanganate webinar. Today we have presenter Mr. John Bull with Carus Corporation, and I am Liz Mueller with Carus. Just a few housekeeping items before we get started. We do have everyone in listen-only mode. If you have any questions, please go ahead and enter those into the questions pane that you can see there on your right-hand side. As you think of those questions, we should have time at the end to get to those questions. If for some reason we don't get to a question, we'll have your contact information and the question that you asked, so we'll be able to follow up with you directly after the webinar. Also, we are recording today's webinar, and we also have the slides available as a PDF. So if you're interested, you can reach out to Dylan Kemmer, who is our lead generation specialist with our marketing group, or you can reach out to myself as well, as you have my email addresses from registering for the webinar. Here's a few ways to be able to find us. We've included our website, our sales and marketing email address, as well as my contact information. Also, we encourage you to follow us on our social media platforms and connect via LinkedIn to our regional sales managers that you're familiar with within your territories. If you're not currently receiving our email list, you can see here a screenshot on each of our landing pages on our website. On the right-hand side, you'll see an option to join our email list. You can click there, and then you will be able to select the industry in which you would like to receive information about. Lastly, here is on our website where you can find our webinar information. So either under the water or the remediation tab under webinars, you can find any upcoming webinars or any recordings that we had previously hosted and recorded and posted on our website. And now I would like to introduce our speaker. Our speaker today is Mr. John Bull. John is currently the Global Technical Program Manager for Carus Corporation. John has been with Carus Corporation for over 45 years, serving in a variety of sales and marketing positions. The Technical Service Department provides chemistry and applications customer support, including on-site lab testing and plant-scale startup and troubleshooting services. John often presents both externally and internally, as well as webinars on topics of permanganates and others. John earned his BA in engineering from Purdue University, West Lafayette, Indiana. He is a member of the Water Environment Federation, WEF, and the American Waterworks Association, AWWA, where he served as the AWWA Illinois Section Chair from 1992 to 1993.
All right, thanks Liz for starting us off, sort of teeing up the webinar, right? How's that for a springtime baseball and golf reference? I have my lab coat on and my safety glasses, so we're all set to talk about permanganate safety today, right? Let me add my welcome to everybody who's attending. Glad that you could be part of the presentation. My goal is really to provide a broad overview of important safety issues and to briefly introduce the idea of global harmonization and its impact on permanganate products. Chemical safety is a complex topic with many components, and a safety seminar should really address a variety of important topics, including those such as regulatory standards, worker exposure, chemical reactivity, disposal of wastes, and ultimately to the disposal of empty packages as well. I'll briefly touch on each of these topics in the next hour, but remember that we have many safety experts on staff who stay up to date on the latest information and can always be consulted at any time after the completion of this webinar. So let me start by saying that Carus Corporation is a member of the American Chemistry Council, and as a member, we participate in the ACC's Responsible Care Initiative. There are several important principles that form the program, and you can see them listed here on the slide. but none more important than to protect the safety of our workplace staff and also the safety of our customers. And today's program is really one part of our ongoing customer safety communications effort. In particular, I would highlight the 2 bullet points that you see here, because we want every employee to arrive safely at work each morning and return to their home safely each evening. We emphasize understanding and practicing chemical safety, and our annual company goal is 0 recordable incidences. We want the same for your workplace as well. Training seminars such as this one are part of our product safety communications program, and our goal is to continually upgrade and improve the information and the way we communicate it. So let's get started by reviewing some chemistry. And first, a reminder that we're focusing today on permanganate products only. And permanganate is part of the broad chemical category identified as oxidizing agents. It's also a manganese chemical. And the properties of oxidizing agents and manganese compounds drive the rules that govern permanganate's safe storage, transport, handling, and disposal. Permanganate products are manufactured, packaged, and delivered in one of 2 forms: crystalline solids and also concentrated liquids. And there are 2 important concepts to consider. Regardless of the form, they have the same active ingredient, which is the permanganate ion. However, they differ in their concentration of this active ingredient, varying from nearly 100% as a dry product to 40% or 20% as water-based liquids. These changes in form and concentration drive the speed of permanganate's reactivity and the associated cautions about its handling and use. Remember that the hazard communications that you're really most familiar with, the safety data sheet and packaging labels, have been prepared specifically for the specific products that arrive at your location. Since potassium permanganate in its dry crystalline form is the highest concentration, the most severe cautions and warnings generally are associated with this product. This concentration effect and its impact on the hazardous nature of permanganate is sometimes difficult to understand. So here's a visual aid to try and help explain this idea in a slightly different way. Notice that the graph is logarithmic on each axis, and it's really divided into 3 zones. Green is low risk, yellow moderate risk, and the pink or salmon color is a high risk situation. And here's what the diagram really illustrates. The hazard potential for a permanganate product increases with its increasing concentration. When permanganate is dissolved in water to less than about 6%, the risk is in the green zone, where most hazards are not significant. This is the common solution strength when working with solid permanganate, because its aqueous solubility is limited to 6% or less at room temperature. Notice that the liquid permanganates are manufactured and packaged at much higher concentrations than 6%. Typically, they're available as 20% or 40% concentration. This moves them up the graph into the yellow cautious zone. They are reactively aggressive in this particular range. And then finally, as you might expect, the dry crystalline permanganates, which are manufactured as 98+% purity, have the greatest potential for hazardous reactions when mixed with incompatible materials. Now, on a side note, but still somewhat related to product safety, we receive many questions about materials that can be used when storing and feeding permanganate products. We have prepared some guidelines and suggestions for compatible materials for each permanganate product. Because the product concentration change the materials guidelines also change. These guidelines are based on experiences in our manufacturing plant, also from published references by materials and equipment suppliers, from lab screening tests that we've conducted, and most importantly, from customer experiences. New materials are always being developed, and if we're not familiar with them, we can run simple tests to determine short-term acceptability. We are not, however, a full-service materials testing facility. Unfortunately, common materials may be sourced from different manufacturers, and they may be produced in different grades. Particular material that has been known to work well in one case may work poorly in another, often without explanation. Be sure to contact us and we'll be pleased to share our experiences with different materials and how they react with our permanganate products. So I would add also that I just learned that March is Workplace Eye Safety Month. And in the case of permanganate, especially in our manufacturing facility, eye protection is our #1 priority. Each year we experience several minor incidences where employees get permanganate dust in their eyes. And so we've changed our procedures, and going forward, we are going to be using fully sealed safety glasses in our plant. So fully sealed glasses have a gasket material that helps them fit tightly to the face. There are many styles that are available. They can come in anti-fogging and prescription lenses. And remember that these glasses are not a replacement for goggles when working with liquids. Now let me set the stage a little bit for the rest of the safety information that we're going to be digging into as we move forward. The first step of worker safety is really knowing the risks and what can hurt you and how it can happen. And there are really 3 situations that define potential hazards of permanganate use. #1, there can be unanticipated reactions with incompatible materials. This situation is potentially hazardous when concentrated permanganate products are mixed together with substances that it can chemically react with. Because the permanganate is concentrated, a mixture such as this will generally generate and release heat. And remember, the permanganate does not react with all substances, only with a select group of reactive materials. The second point would be the environmental hazards that may occur due to a large release of potassium permanganate. That release may adversely affect aquatic life. Or if the permanganate is improperly disposed of, it can result in unanticipated reactions with incompatible materials, as in point #1. Regarding human safety, exposure to permanganate may be internal by ingestion or inhalation, or external such as skin, eye, or clothing exposure when handling it or due to spills and splashing. Most of the health effects hazards are associated with daily, chronic, long-term exposure, such as what we might encounter in our factory. For most users, short-term exposure issues are more important where sensitive tissues, such as eyes, may be exposed and result in injury. Worker protective equipment is always required. Now, communicating potential hazards and precautionary actions, specific worker protections and remediation options is accomplished through a variety of different methods. In addition to seminars such as this one, the common routes are shown here. As our understanding of product applications evolves, or as regulations change, these communication routes may be reformatted or revised. And this brings us really to global harmonization, or the Globally Harmonized System for Hazard Communication. Today, there's a drive toward consistency or harmonization in the way information is delivered worldwide. And our presentation is in part designed to inform you of changes that have impacted permanganate product safety communications. The safety data sheet, SDS, is still our most important safety literature piece. As of June 2015, the GHS compliant safety data sheet replaced the previous material safety data sheet, MSDS. This switch to a new name signals that there have been some changes. For example, there is a new 16 section format that applies to all SDSs. Also of special note, new red, black, and white pictograms are part of the new format as well. The safety data sheet is available for crystalline permanganate, and all of the cautionary information relates to that dry material, which is nearly 100% active. When it is stored and handled properly, it is stable and easy to use. But it is an oxidizer, and if the dry powder is mixed with incompatible materials, it will generate heat. However, when it's dissolved in water as a dilute solution, most acute hazards are eliminated. It's also self-limiting because at room temperature, the strongest water solution you can make is 6% by weight. Remember that water is your friend when working with permanganates. A new safety data sheet is also available for permanganate liquids, and all the cautionary information relates to the concentrated products as they're delivered. As with dry permanganate, when concentrated liquids are stored and handled properly, they are stable and easy to use. There are no vapors that are released from permanganate solutions. Concentrated liquid permanganate is an oxidizer, and if mixed with incompatible material, it will generate heat. However, when it's dissolved in water as a dilute solution, most immediate hazards are eliminated. Remember that water is your friend when working with permanganate. Now here's some information on the new health hazard pictograms that are required for crystalline potassium permanganate products. These pictograms apply to all package sizes. The health and safety categories are also new, and they are based on the latest research data. There are 4 categories in the toxicity rating system, with category 1 representing the greatest hazard, and category 4 being the lowest hazard class. And you can see that acute oral toxicity for permanganate is in this lowest class. There's a separate rating system for corrosivity and irritation potential. In the case of corrosivity, there is only category 1, but with A, B, and C subcategories. If you'd like to know more detail about the category definitions, the OSHA.gov website will provide all of the appropriate tables that you can reference. Liquid permanganate also has new health hazard pictograms. These pictograms apply to all package sizes, and the health and safety categories are also new, and they're based on the latest research data. In addition to new pictograms, signal words, hazard statements, and precautionary statements are new to permanganate labels. They're designed to better define the health and safety impacts of the product being used. If signal words are required, there are only 2 to choose from: warning or danger. And in the case of permanganate, the signal word is danger. This is the permanganate precautionary statement. The wording is specific to permanganate and linked to the physical hazards associated with oxidants and specifically with permanganate. This is the hazard statement for permanganate. It reflects the potential health hazards as well as the oxidizing chemistry of permanganate. For example, it identifies the fire hazard potential. This is a new pictogram for permanganate, and it's the only environmental hazard that applies. Because permanganate's environmental impact is related to the quantity of material that may be released, this pictogram is applied to only large package sizes. Lastly, this new GHS pictogram reflects the oxidizing nature of permanganates. The physical hazard criteria are available if you'd like to see more of the detail. I might add that permanganate itself does not burn. When it gets hot, it will decompose and release oxygen, which is the nature of oxidizing agents. In order to actually have a fire start, there needs to be some type of combustible material also present. Now let me address worker safety and PPE. And let's start with the inhalation exposure. Inhalation exposure scenarios for permanganate products, for the most part, apply only to the dry crystalline powders. When transferring the material from its package into a storage hopper, a fine dust can be released. This caution also applies to any situation where permanganate is air conveyed into a storage silo. It may be possible, however, to imagine a situation where a fine mist of liquid permanganate is generated and a worker could be exposed. It would be rare, but it could occur if the concentrated liquids are being spray applied, or if a line under pressure has a small cut or leak and material is misted out. Permanganate dust is an irritant, and breathing it should be avoided. Permanganate is a manganese compound, and inhalation exposure is based on manganese ceiling value of 5 milligrams manganese per cubic meter of air, and a time-weighted average of 0.1 milligrams of manganese per cubic meter of air. Eyes are very sensitive tissue and must be protected from permanganate dust, particles, and liquid droplets. Dry permanganate crystals are sharp and abrasive and can scratch the eye surface. Plus, the crystals carry a small amount of alkali from the manufacturing process, or the permanganate might react with eye tissue to form alkaline products. This alkali could produce a corrosive burn. Eye protection is very important, and I would specifically mention that safety glasses with side shields are no longer acceptable when handling dry potassium permanganate. And our most recent recommendation is to use goggles when handling the concentrated liquids. And for either type of permanganate product, the new glasses that seal along the face. Permanganates will react with skin oils, producing a brown stain. Highly concentrated permanganate liquid may attack the skin or other contamination that might be on the skin. Gloves should be worn when handling permanganates. We use chemical-resistant PVC or Teflon-coated gloves whenever handling permanganate, and cotton gloves really should not be worn. And as you can imagine, regarding ingestion, as with all chemicals, concentrated permanganate products should not be ingested. Now, I want to make a few comments about how permanganate should be properly stored and potential hazards that you should be aware of. Permanganate products are manufactured and packaged in containers made of compatible materials. But when permanganate is repackaged in the smaller container sizes, the proper container materials should also be used. Under normal conditions, permanganates are very stable and have a shelf life of many months. Cautionary statements regarding proper storage reflect concerns of accidental leakage or spills from the original packages. mixing with incompatible materials on, say, a warehouse floor or in a drainage system. In a warehouse, be aware that a lift truck forks may puncture a permanganate package. Permanganate that leaks from a damaged container can react with lift truck brake fluids or antifreeze on the floor or on the decking of a trailer. Keep permanganate separated from heat sources, other concentrated organic chemicals, and from concentrated acids. In recent years, dry crystalline permanganate, potassium permanganate, along with many other oxidizing agents, has been added to the list of chemicals that could possibly be used by terrorists to produce a dangerous reaction. The CFATS standard limits the quantity of permanganate that can be stored at an industrial site where there is inadequate security in place. The maximum quantity is 400 pounds. However, following a top screening where proper security measures have been verified, inventorying large quantities may be permitted. Municipalities are exempt from the CFATS standard. And our authorized distributors comply with the standard by installing property fences, secure gates, and surveillance cameras. I mentioned earlier that permanganates are normally very stable and that they're also not flammable. However, when an oxidizing agent such as permanganate is involved in a fire, or if they're exposed to a heat source, they could decompose. And this decomposition releases oxygen, which will help to sustain or accelerate a fire. Fires involving permanganate cannot be extinguished by smothering with inert foams. Only water is effective. Here's the NFPA hazard descriptor that is common in most storage areas and near different types of storage tanks. The NFPA hazard code is used to communicate valuable information to first responders. Of special note, the NFPA Health Hazard Code, the blue quadrant, has been revised for permanganate, and it's been revised to Category 3. This reflects that irritating byproducts could be formed during a fire. The NFPA Hazard Code is used to communicate information to first responders regarding the liquid products as well. And you can see that the hazard communication is slightly different for the liquid products, especially in terms of the flammability hazard. If permanganate is involved in a fire, remember that you cannot smother the fire involving permanganate because oxygen is being liberated. If a fire occurs and permanganate is involved, large quantities of water must be used as the extinguishing medium. Product spills can and do occur. If dry permanganate is spilled, sweep up the material and transfer it to a clean metal drum. Do not return the spilled product to the original package if that container still contains potassium permanganate. Floor sweepings could include reactive materials that will contaminate or react with the permanganate in the drum. If liquid permanganate is spilled, it should be contained and diluted with water to less than 6% concentration. The weak diluted solution can then be neutralized with common dechlorinating or reducing agents such as sodium bisulfite. There are a number of diking type materials that are available on the market that are found to be compatible with 40% liquid permanganate. And they are good to have on site where you're using concentrated liquids. Remember that water is always your best friend when working with permanganate. If concentrated liquids are spilled, do not try to neutralize them directly until they're diluted with water. Do not wipe up spills, clean up drips or leaks, or wipe down equipment with a dry rag. Have a bucket of water available and wet the rag with water first. After using the rag to clean up a small spill or a drip of liquid permanganate, rinse it in water to get all of the permanganate out. Permanganate diluted with water to make a weak solution can be neutralized by reducing it with commonly available dechlorinating or reducing agents. When the permanganate is gone, there will be no purple or pink color visible. The remaining solution is then non-hazardous, and it can be disposed of according to local regulations. Neutralizing solutions can be used to remove the brown permanganate stains from floors or equipment. The reaction will change the purple permanganate color to brown and then to clear as the reaction proceeds. Brown stains on hands or equipment can be removed by preparing a fresh solution of water, household vinegar, and 3% hydrogen peroxide. These materials are available in the local grocery store. And you can see the ratio that we recommend for making up this cleaning solution. This cleaning solution is not particularly stable, so it's better to keep the individual components separate until you need to produce the cleaning solution or make it up, and then use it right away. If you are transporting or shipping permanganate products, the U.S. Department of Transportation hazardous materials regulations are still in effect. When shipping permanganate, the proper packages, labels, placards, and documents must be used. Although there are new GHS requirements, the U.S. DOT still requires that the yellow diamond oxidizer label and placard be used on packages and over-the-road shipments of permanganate. This requirement may vary depending on the size of the package. The shipping documents must show the proper shipping name, the UN number, and any reportable quantity. There are two acts, U.S. acts, that regulate the release of or disposal of permanganate into the environment. And they follow the EP toxicity or extraction procedure toxicity testing. RCRA governs how hazardous waste may be disposed of. Permanganate as an oxidizing agent contributes to the ignitability of waste and is therefore considered to be hazardous. It may not be disposed of into a standard sanitary landfill. CERCLA, which governs Superfund sites, is the act that establishes reportable quantities for chemicals. Under CERCLA, dry permanganate products fall into the 100-pound or greater reportable quantity category. That means if permanganate is spilled into the environment at greater than 100 pounds, it must be reported to the National Response Center. Disposal of permanganate products into a chemical landfill may be permitted. For small quantities, destroying the permanganate via neutralization can be a viable option for disposal. And remember to rinse permanganate drums thoroughly before disposal of those packages. Now there's a lot of additional information that's available, and for those of you who have read through the safety data sheet, you know that it's full of really good information. So please feel free to contact your local account manager or request information via our website. And feel free to contact us if you have any particular questions.
Great. Well, thank you, John. And here is a look at our contact information for our regional sales managers. So we have the U.S. contacts here on the left, and then we have our international contacts on the right on this screen here. So please feel free to reach out to them. You also have our contact information in case you don't remember after this webinar, the emails. And then additional contact information, we've got both John's information here and then our EHSS representative, Shelley Corbin's information as well. So we'll leave it here on this slide as we go through our question and answers. So just as a reminder for everybody, if you have any questions, go ahead and type those in. We see a few coming in. Today's webinar has been recorded, and we do have available both the recording and a PDF of the presentation, so feel free to reach out to us and we're happy to share those. So a couple of the questions was, you had mentioned about the difference of the eyewear for potassium and sodium permanganate. Could you mention those again?
Yes, we've just changed our recommendation for dry crystalline potassium permanganate because we have found that standard safety glasses with side shields leave too many gaps where dust or particles can get in behind the safety glasses and into a worker's eye. So we've changed that to glasses, safety glasses that fit tightly to the face, usually by using a soft material or gasketing material on the inside of those glasses. And it prevents particles from getting in behind the glassware. Now, they don't work perfectly well for liquid splashes, so we still recommend that if you're dealing with liquids, the best eye protection is to use goggles to protect the eyes, and also a face shield to protect the full face as well.
Okay.
I might add, Liz, by the way, before the next question, that if you have a question about the specific brand of glasses that we have been working with, I'm sure we can get that information from our manufacturing plant.
Yep. All right, and then one question about where can we access the SDSs, so I can take that question. So we do have a section on our website, caruscorporation.com, where you can find the SDSs. If you're not able to easily locate that, again, either get in touch with your regional sales manager or you can email our sales and marketing email address, and we'd be happy to share those as well. Okay, so another question coming in is, what is the best way to neutralize caustic liquids that have residual potassium permanganate mixed in? Is it a two-step process that first uses sodium bisulfite followed by acid? If yes, which acid? Can acid alone be used? If yes, which one?
Oh, that's a great question. So yes, the neutralization reactions really occur only under slightly acidic conditions. So if it's highly alkaline, you will have to neutralize the alkali first in order to get that reaction to go. And typically we would probably use dilute sulfuric acid to do that sort of neutralization. You'll notice if you look closely at the neutralizing agents, they are all slightly acidic, especially the slightly acidic reduced sulfur compounds. And so in a neutral solution, they will drop the pH on their own. But you're absolutely correct. If there's alkali present in the system, you have to neutralize that first. And typically we would use sulfuric acid. That brings up a very important point, and you would see this by looking at the SDS. You never use hydrochloric acid to neutralize any type of permanganate solution, because under acid conditions, the permanganate and also the manganese oxides that are produced from permanganate actually will convert hydrochloric acid and produce some chlorine gas. So be sure to avoid hypochloric acid and hydrochloric acid, and stick with sulfuric as your neutralizing agent.
Okay. And I just might add, so in terms of neutralization products or ratios, we do have a literature piece that we have available. So John had mentioned the cleaning solution and the ratio. That's also on that document. So if you're interested, let us know. And a couple other things John had mentioned in the webinar. We also have materials compatibility literature that we'd be willing to share as well for both our potassium and sodium permanganate products. Okay, one more question. Isn't sulfuric acid also incompatible with permanganate?
Well, the recommendation again, and I apologize for harping on this so heavily at the beginning, but a lot of these reactions have to do with the concentration of the reactant and the concentration of the permanganate. So you'll see a very important warning on all of the safety data sheets that says do not mix dry crystalline permanganate with concentrated acids. So absolutely that is a fundamental restriction on using any type of acid with permanganate. But if you have a permanganate solution and you have diluted sulfuric acid, they are compatible and can be used together to produce the pH that you're shooting for or targeting. And we do that all the time. But the caution is with dry crystalline permanganate and concentrated sulfuric acid that should not be mixed together.
Okay. It looks like no more questions have come in. So again, we thank John for presenting. We thank all of our attendees. And if you think of any questions when we conclude the webinar, feel free to reach out to us and we will get that information to you. Thank you, everybody.